Welcome to the Westport Library. Today's program will begin momentarily. Supported by Verso Studios, created locally and shared with the world.
Good evening, everyone. I'm Jennifer Tooker, and I am Westport's first select woman. And it is my pleasure to welcome you all tonight. This is a fabulous crowd, and a Happy New Year to all of you. I think some of you have probably been with us before, and maybe we have lots of new faces in the crowd tonight. I get the honor of introducing, because you don't want to sit here and listen to me, I get the honor of introducing Cliff Serlin, who is a friend and a Westport resident. His day job is he's an investor, but in his spare time, he and the StartUp Westport team have a vision and a plan to make Westport the tech, startup, and innovation hub of Connecticut. And I feel so lucky. It is my honor to work with this team to make that vision a reality. And so thank you to all of you tonight for being here, being part of our journey. And without a further delay, I will introduce to you Cliff Serlin.
Jen, thank you so much for those very kind words. As Jen mentioned, my name is Cliff Serlin. I'm the president of StartUp Westport. It is my privilege to welcome you all here tonight for what we hope will be an action-packed evening discussing one of today's most interesting and controversial new technologies. We look forward to hearing more about artificial intelligence from Dan Bikel and Peter Propp in just a few minutes. But before we get there, I want to catch everybody up on the activities here at StartUp Westport. It's been a very busy few months here, and as you can see by tonight's attendance, our membership continues to grow. As many of you are aware, tonight's event was sold out. We had over 400 registrants tonight, which is an important milestone for us. I thought I'd share some of the numbers that best capture the spirit of StartUp Westport. We have over 650 registered members. The open rate for our newsletter is north of 80%, and our click-through rate is north of 25%. So, as you hear, we are a digital marketer's dream. We also have consumed over 15 cases of wine and 25 cases of beer together over the past year, and I'm sure that'll go up after tonight. We've officially incorporated, which means StartUp Westport Inc. is open for business. We've recently submitted our 501c3 and hope to officially become a nonprofit organization at some point in 2024. I want to call out Mike Minahan and offer a profound thank you for leading us through this process. Mike has spent countless hours getting us to where we are today. So Mike, I know you're here. Can you stand up? Thank you. Thank you, Mike. Now that we're official, we plan to accelerate our fundraising activities to support our ambitious 2024 goals. I'd like to say a big thank you to the Wiggin & Dana law firm for becoming our first official sponsor. We held a great holiday party in December, sponsored by Wiggin & Dana, and greatly value our expanding relationship with Seth Greenstein and his team. There are multiple Wiggin & Dana partners here tonight, so I encourage you to hit them up for some pro bono legal advice. Over the course of the next month, we plan to speak more about our fundraising efforts, and if anyone here would like to find out more about sponsorship opportunities, please reach out to me later in the evening. Tonight is also a very special night. I'm super excited to introduce the StartUp Westport Mentorship Program. This initiative, which will be headed by Noah Fan and his committee of volunteers, just launched. Noah and his team have spent the last few months building this program. I had originally hoped that Noah would be here tonight to introduce the program himself, but he is currently at CES in Las Vegas, so I have the honor of telling you about our plans. As you are aware, here at StartUp Westport, we are a community group of established business leaders with a goal of activating and enabling entrepreneurship and innovation. To further this mission and provide value back to the community, we've created the StartUp Westport Mentorship Program. Since Noah was unable to join us this evening, I've asked him to pre-record a short video sharing his thoughts about the program. So let's hear from Noah about his vision as well as his plans for our 2024 pilot. Alex, please run the tape.
Good evening, StartUp Westport. My name is Noah Fenn, and I'm joining you virtually from Las Vegas. I'm at a tech conference this week and unfortunately can't be in the room with you all tonight. I'm a Westport local, a husband, a father of 3, and a tech startup VP. Mentorship has played a real pivotal part in my 23-year professional journey, both as a mentee and a mentor. It's a powerful tool for growth, offering knowledge transfer, support, and accountability. Today, I'm thrilled to announce the StartUp Westport Mentorship Program. This represents our commitment to nurturing the next wave of entrepreneurs in Westport and surrounding communities, encouraging collaboration and bridging the opportunity gap for historically marginalized groups. Our 2024 pilot consists of large group mentorship meetings with fireside chats, smaller topic-based mentorship circles, and a comprehensive mentorship guide with best practices to ensure that everyone gets value throughout the process. If you're interested in applying to be a mentor or mentee, please email mentorship@startupwestport.org or scan the QR code that Georgie has on display in the room tonight. Georgie, if you can just raise your hand real quick so folks know where to find you. Together, we'll make Westport a hub for entrepreneurship, innovation, and professional growth. I look forward to going on this journey with each of you.
Great. Thank you, Noah. Is Susan here? Susan Fan? Oh, she is. Hey, Susan. Great. Okay. So we've been approached by many of you asking how you can help support our efforts here at StartUp Westport. This is a wonderful opportunity for people to step forward to volunteer. So if you're interested to be a mentor or a mentee, please take out your phone and scan this QR code or that QR code or find Georgie later, and Georgie will have all the information. So great opportunity for you all to get involved. A big round of applause for Noah, Georgie, and the mentorship team for all their efforts. So staying on the Fan family, I want to call out Susan Fan. Susan has worked tirelessly on numerous StartUp Westport initiatives. Her steady hand has helped us create a wonderful series of events. I guess we can say the Fans are the first couple of StartUp Westport, so thank you, Susan. All right, next. I am pleased to announce the upcoming slate of super cool StartUp Westport events that will be held here at the library over the next few months. First, on Thursday, February 29th, in celebration of Black History Month and in partnership with the Westport 10, we'll host a forum on past, present, and future opportunities for diverse entrepreneurs. Local business leaders from film, TV, music, real estate, retail, and technology will share their stories. StartUp Westport's very own Jay Norris will spearhead the event, and I'm sure it'll be an amazing evening. So please plan to join us on Thursday, February 29th. Leap year, exactly, an extra day, and we'll make the most of it. Next, on March 18th, Galia Gishan from the Tidal River Fund will host an investment forum featuring female founders and investors. Galia has assembled an impressive group of female founders, CEOs, and investors who will talk to us about their individual journeys and experiences in raising, investing, and launching early-stage startups. Finally, on Thursday, April 25th, we'll have the pleasure of hosting Westport's own Jimmy Patero. Jimmy is the chairman and chairman and CEO of ESPN, who will speak to us about how ESPN plans to embrace technology in the future of sports broadcasting. So as you can see, we're busy at work here to make 2024 an amazing and incredible year. As with anything and all things we do here at StartUp Westport, it's important to recognize the people who make this all happen. A huge shout out to our amazing first select woman, Jen Tooker, and our real-life superhero police chief, Fodi Koskinas, who's now serving as a bartender. Thank you both. Also, a big thank you to the entire Westport Public Library staff, whose support here has been invaluable. We greatly appreciate the partnership that we have with the library and look forward to expanding it. Where's Alex? Giannani is inside, and he said you don't have to name everybody, but I'm just going to name a few people and then extend my thanks to everybody else. So thank you, Bill Harmer, Alex. Unfortunately, Bill is the executive director. He couldn't be here tonight. He was struck by an illness, so we will miss Bill and we wish him well in his recovery. Melanie Myers, David Bibby, and the entire audiovisual staff who's here this evening working tirelessly to make this night a success. So thank you to all these people around who are helping us, and we greatly appreciate all of your efforts. Thank you. All right, and now, without further ado, I am pleased to introduce the stars of the evening tonight, Dan Bikel and Peter Propp. I will let Peter provide the greater context and more about Dan's very impressive background. Enjoy the evening, and thank you again for the continued support.
Well, thanks, Cliff, and good evening, everyone. I'm happy to be your host for tonight's Generative AI event, and we're really excited to see another sellout event for StartUp Westport. In addition to tonight's main event, we are also starting a new tradition of an after party. So where those who want to spend more time with the StartUp Westport community can help support local bars and businesses and restaurants. So tonight, the after party is at Verso, which is just across Jessup Green. So if you're so inclined, please meet us at Verso after the event tonight and buy yourself a drink, buy your friend a drink. The library's also already hosted some terrific events on AI. Tonight we have the unique opportunity to hear from a top generative AI researcher to help us understand how AI works and where it's going. Dan Bikel has had an outstanding career in computer science, from Harvard to Penn, BBN, IBM, Google, LinkedIn, and Meta. Dan's about to tell you about some of the cutting-edge projects he's driven and supported. More importantly, he's going to take some time to share how generative AI operates. But before we begin, I'd like to take a minute so we can know a little more about you in the audience. So I want to do a little show of hands. How many of you work in the field of technology? Okay. How many of you, we should leave our hands up. Okay, that's good. Okay, how many of you are coders, architects, or engineers? That's not bad, actually. Okay, cool. Okay, a general question. How many of you overall are excited about AI? We're all excited about AI. How many of you are excited by AI, but a little bit nervous? Okay, good. So we really do have a very technically oriented crowd. So you're really going to eat up the information that Dan's going to share. For those of you who have not spent much time in the world of computer science, I want to encourage you to listen and observe what Dan's talking about without feeling like you have to know and understand every concept. Tonight's talk is being recorded, so you'll be able to go back and watch it on YouTube if you need more time with the content. But for now, it gives me great pleasure to welcome to the stage Dan Bikel.
All right, hello everyone. Oh, let me do this. Great to see you all here. I'm Dan Bikel. I want to first express my gratitude and thanks to Cliff, Jay, Peter, who am I leaving out? Sam, all of our partners at StartUp Westport. So I'm not just the speaker tonight, but also part of StartUp Westport. I want to give a special shout out to Jen Tooker and Chief Fody, because this is a public-private partnership, and so without the public part, that's half that's missing. So thank you all for your wisdom and support. And I want to give a special shout out to my dear friend Stefano Pacifico, because without his efforts, this StartUp Westport got off the ground because of him. He's the one who called me a year and a half ago, however long it's been. And and now we're really cooking with gas here. So this is great. All right, so let me get to my talk. All right. We should see it shortly. Yes. All right, so I'll be talking a bit about what I do, which is I'm a research scientist in generative AI. And I'm also a natural language processing researcher. So I'm going to be talking about all of these things: natural language processing, machine learning, and crucially, large language models. And part of what I want to do tonight is give you an idea that hopefully will be accessible to everybody here about how these things work. I want to demystify how large language models work. Some of you in the audience, we have a pretty astute crowd, may know exactly how they work, but many people don't, so I just want to give you a good idea about that. So let me just gloss over this. I've worked at a bunch of different places. I've done a bunch of different things. I spent a lot of time at Google Research, and I got to work with outstanding people there. And for the last year and a half or so, I've been at Meta, which is the company formerly known as Facebook. And I have outstanding colleagues there, and I'm having a great time working on generative AI. All right, so I should almost pose this to the audience, but what is natural language processing? So this is the field I've been in my whole career. It's basically about having machines build useful representations of language. And that sounds kind of complicated, but basically it means, can we have words that go in to the machine, and the machine has some representation of the meaning of those words so that it can do something useful? So when I say do something useful, really it means mapping inputs to outputs. That's what we computer scientists always do. And so, for example, one of those really useful things is translating from one language to another. This is kind of the NLP problem, is machine translation. But there are a whole host of different NLP applications, and I have a bunch of them here. I've worked on all of these, actually. So yeah, semantic parsing, question answering, automatic knowledge graph construction, image captioning, information extraction. There's so many different problems that involve text, either text coming in, text coming out as part of the problem. All right, so let me try and demonstrate a little bit about how these things work. So one of the things I do is build generative AI models that are chatbots. So let's see if we can have a little conversation with Max. There's no internet connection. Should have checked that before. Hold on a second. Yeah. Right. That's hilarious. Where are we? Yeah. Public Wi-Fi. Yes, excellent. All right, let me try this. Let's try that again. The demo gods, yeah, okay. So this is, can you see this, by the way? All right, great. This is Max. So one of the things that we've launched, and I say we, it's the large organization I work with, at Meta, is a bunch of character AI agents. These are characters, and some of them are played by famous people. So one of the cool things of working here at Meta is that the boss of the whole company can proverbially, pick up the phone and call famous people, and sure enough, you have a famous chef like Roy Choi who's playing the role of Max. So, I might want to talk with Max and say something like, you know, hey Max, name's Zach, and I want to plan a party. So, you know, Max is a chef character, and he knows a lot about being a chef, and I can carry on a little conversation. I can give some constraints like, oh, well, I want to plan a party for my friend Zach. You know. So, yeah, I can carry on this conversation and have a lot of interesting things to talk about, and he can help me plan my party. I say he, it's an agent, it's an AI agent. So the whole point of showing you this is that these interactions are natural, and they're, in this case, they're helping me out. If I really did have a friend named Zach that I wanted to plan a party for, and Zach was a vegetarian, you know, forgot to mention Zach, you know, dislikes chocolate, right? So I can tell about all these things that are constraints, and then I can get recipes, and I can help plan the party. All right, let me get back to the talk, and I'll talk more about how these things actually work, and what I do to help build these things with my team. All right, so, great. So these things are, how many here, if you could raise your hand, I'm gonna do another audience poll. How many here have heard of deep learning as a concept? Almost everybody? Okay. Well, so these are all built with deep learning methods or neural networks. So here's what neural networks are not. They are not, with a few exceptions, they are not trying to be simulations of the human brain. They've got the word neural in them, but they're not actually neurons. They are very, very loosely inspired by neurons, hence the name. So what they really are is a set of methods, many of which have been known for a very long time, coupled with lots and lots of data and lots of floating point processing power, lots of computing power, and then we can do amazing things, especially now. So why do we need so much processing power? It's because we don't exactly get this power of deep learning for free. We need more compute than we used to with the methods that came before, that were popular before deep learning has its heyday right now. So I wanted to present a couple of technical looking slides to you guys. To some of you, this is gonna look familiar. To many of you, this will look unfamiliar. But this is, believe it or not, a very simple version of a neural network. And I wanted to show what it looks like. You're seeing a bunch of circles, and a bunch of circles with squiggly lines in them, and a bunch of arrows connecting them. This is where part of the power lies, that each one of those circles is called a node or a neuron, and they're all feeding each other information. You might start with the input words, say, at the bottom, and each successive layer, this is the deep learning part, the deep part, is producing a new representation. You can think of it as getting more and more abstract as you go up. It doesn't have to be that way, but it often is. And the squiggly lines are really important, actually. One of the older ways that we used to do things is we would build what are called linear models of data. That basically means we're trying to find the best line to approximate some data. But the squiggles here, they matter. If you combine a bunch of lines together, you just end up with a line. If you combine a bunch of non-linear functions, then you get an exponential increase in what they can represent. This is part of the power of deep learning. All right. And the other technical thing I want to mention, and then I will show you how these things work, is transformers. So you could ask, are large language models, are they a revolution? Maybe, but it's debatable. I would argue that the real revolution, if there is one, was the introduction of a particular way of building a neural network called the transformer. And this was way, way back in 2017. There was a paper entitled "Attention is All You Need," written by a bunch of my erstwhile Google colleagues. So what is this architecture that has become so important? And what is attention? So let's take a look at it. You do not have to understand this complicated looking thing, okay? But I wanted to put it up here because, again, this type of model, this is what has swept through AI. It started with machine translation and natural language processing. It then moved on to speech recognition, and then now it's being used in virtually every area of AI. Image generation, image captioning, video understanding, video generation, robotics, drug discovery, you name it, this architecture is important. So, this is the black box of AI, if there is one. But it's not black, it's not a black box, it's a transparent one, and I'm showing it to you right now. So, yeah, there are a couple of things that are really key to know about this thing. One is attention. I'll explain what that means here. And the other thing, I'm just going to gloss over. Let's just focus on the attention part. So this is what attention is. We're going to look at a sentence here. Attention is, in a very real way, a way of having words be modeled by their surroundings. So when you're listening to a sentence or reading a sentence, you understand things in context, right? So what does a word like it, a pronoun, refer to? What does it mean? Well, it's only by paying attention to other words in the context that you understand what it means, right? So attention here is learning, the model is learning how to put weights on the different words in context so that you can understand, or so that it can have a good representation for each word in context. That's what attention is. Super, super important concept. This is in fact called self-attention because it's the words paying attention to themselves. The other thing that's super important, and here's like the meat of how these models work. And if there are only two things that you come away with, I'd like you to remember attention and what we just saw, and this. Large language models predict one word at a time. They do that given all the previous words that have come before. That is fundamentally how they work. And they use all the words that have come before to help. What is the next most likely word in this sequence? That's what a language model is, after all. So this is what it looks like. The model needs to understand, well, how do I represent the word quick given the, and what is the best next word after this? Well, maybe it's fox, right? And you can generate whole long sequences this way. This is how these models are working, one word at a time given all the previous words. So some of you already knew this, if you didn't already know this, that's how these things work. And it's kind of fundamental to understand and demystify what's going on underlyingly. There's not some super elaborate machinery in terms of how words are popping out of these things. It's one word at a time. So we've actually been building these types of models for many years now. And ChatGPT, which probably a bunch of you have heard of, is just one of the entries in this increasingly long list of such models. And the reason we can build bigger and bigger models is that we've got lots of text lying around. And when you have text lying around, we say that the model can just learn directly from these sequences of words that occur, rather than having a bunch of expensive processes to label the words. Also, we've got lots and lots of computing power. So this is a quick chart just to show you how these models have been growing bigger and bigger and bigger over time. Bigger does not always mean better with these types of models, but it's just evidence of how we have more and more data, more and more computing power to build these incredibly powerful and sophisticated models. All right, so here's the other piece of LLMs. So what do they do and why are they so important? They're excellent at simulating good-looking, plausible natural language text. All right? So there's no other fancy, deeper process that's going on inside of these models. They're predicting one word at a time, and they're trained on so much data, and with that architecture I presented before, transformers, that they're just very, very good at simulating good-looking sequences of things. Words, could be pixels, could be anything that you're able to model. And they can regurgitate information on which they were trained. They can learn abstractions of their training inputs. And at large enough scales, they can exhibit what people often refer to as emergent properties. It just means things that we didn't explicitly train these things to do, they seem to be able to do, like explain why a joke is funny, for example. All right, so I sort of mentioned this before, but it's hard to overstate. These things have taken over AI. They're revolutionized all of natural language processing, plus related fields. All these fields listed here. Protein folding, drug discovery, sequential decision-making, writing code, robotics, music generation, you name it. And all of these applications, or most of them, and most of the work in them, at some level, are using this transformer architecture. So at the same time, the field I'm in is very boring because all the models kind of look the same. But it's incredibly exciting because we've made such amazing progress in these various application areas over a fairly short amount of time. So that's very cool. Now, I want to end with another little chat with another AI agent. Excuse me, let me take a drink. Called Billy. All right, now Billy, and I have Wi-Fi, which is good. Billy is someone who is, as it says, your older sister and confidant, got a problem, got your back. This isn't just any old AI agent like the last one I showed you, right? Meta is a social networking company. So we're building these targeted types of AI agents that serve specific purposes and that are, many of them, more connection focused. So this is all hypothetical, by the way. I can say, oh, I'm a little worried about my company's return to office policy, and I can have a nice chat about this sort of thing. And right? By the way, it's actually not that bad. So anyway, I wanted to give you a sense of different characters. This one is actually played by Kylie Jenner. Again, kind of nice when all these famous people are happy to lend their image and likeness for these characters. So with that, I wanted to just end my presentation, and thank you very much for listening. Oh, should I leave it up? Yeah, all right. Hold on.
All right, so Dan, that was fantastic. Thank you very much. I really appreciate it, everything you did. And I think we both knew that coming into tonight that the fun was probably going to come right now when we get some questions from the audience, but I've got a few first. The way the questions are going to work, we're going to stand near my friend Jennifer Bangser, where the light is. Let's step and repeat. If you have a question, go over there. You can ask one question. You should not make statements. We would like questions. But I get to go first. So as the line forms, off of your description of the importance of the Transformers idea in 2017, I heard a comment a while back from Sam Altman that we're unlikely to see a bigger leap in AI than OpenAI's release of GPT-3 in terms of not knowing about AI to AI being everywhere. But do you agree with that idea that most enhancements of AI going forward will be incremental, or do you ever expect to see some really big further changes?
I've seen too many big changes to assume that we've seen the last of them. So yeah, my belief is that we are going to see more big changes. And just to give you an idea, this Transformer paper came out in 2017, and then a couple years later, there was one fellow, Jacob Devlin, who developed a system called BERT, and it was extraordinary. Actually, the year before that, there was another fellow who developed a system called Elmo, and Elmo was amazing, solved so many problems. And then the next year, BERT was invented and blew it away. We were like, well, we're not going to see that anytime soon. And then we had T5, and we had all of these different models that were then coming out, every year, and then every 3 months, it seems, and now every week it seems there's something new. So I'm not going to assume, we haven't seen the last of these big changes as they come along. Yeah.
Thank you. So my company recently built the user experience and design for a closed source AI system in the logistics space. So when you think about AI in the business setting, do you have any thoughts about closed source versus large language model systems, and the importance of AI interfaces that end users are going to work with? How should people think about the way they're going to spend their day with a closed system or an open system?
Yeah, I think it all depends on the application. So there's I'm sort of happy and proud to be at a company that embraces open source, and that's great for the ecosystem and the community that it creates, and the set of tools and innovation that it fosters. But then it also helps when private entities and companies then build on top of open source projects, and that happens all the time from all manner of companies, big and small, right? So, yeah, I think it's great when you are able to pick and choose from the services and APIs and which projects you want to take from it. And having open source means that there might be a lower bar of entry. Say if you're a startup, you can take advantage of open source tools and open source projects because the cost is usually free.
Excellent. All right, our first question from the audience.
What you told us really sounds as if everything is done in a predictive way. Yet people like Hinton and other people talk about AI as being an existential risk to humanity. How can you give us some idea of why there is all of this existential risk, and a lot of people saying that the AI development should be paused?
Let's see. So, Jeff Hinton certainly knows full well, all of the details behind the very systems that he helped foster and invent. I think these are certainly larger questions than the technology itself, but I think, I think that there are, real valid concerns with any new technology as to how it will be used, who will be doing the using, and what it makes possible, and there are always risks that come along with that. So now that's true of every technology. So to go from that sort of general, there's a portfolio of risk and reward with any new technology, granted, right? But to go from there to say, like, what is the gap between that and, this technology poses an existential risk? I think there are a lot of a lot of things that need to happen for to make that assertion. And so obviously there's debate in the, I'm just a research scientist. There's debate in the research community about, what do we do with this technology that we're building and the innovation we're having. And what I can tell you is that there is a large part of the research community that is focused on areas of safety and how to safely build safety into large language models, and so that you can make them as safe as you want or need them to be when you deploy them for various applications.
Excellent. Next question.
Why is there a risk? No. Well, I would say that there is a risk if you do something that is, I think you could try to build something that is very, very risky using a large language model or some other similar technology. But I think we're a long way from a model that knows how to predict the next word really well to then going to something that's, that type of existential threat. But I think that the sentiment is a reasonable one in the sense of, well, shouldn't we be thinking about what the risks are? And shouldn't, even if you were to be one of the set of people who believes that they're existential, I happen not to be, but even if you are, great, that's what academic debate is about. So at least in the research community, we absolutely should be debating all of it.
So my question actually builds on that, because I think what you're talking is great, thank you very much, highlights is that a lot of the advances are based on the increase in compute power, and the brute force LLMs, the large data and all that compute power have been really, really good at making us think they're existential threats because they sound like they're real people. But when lay people think about existential threats, they think of Skynet. They think of computers that are going to take over the world and to supplant us. And that comes from what you would consider more general artificial intelligence, as opposed to these LLMs. And so my question to you as a researcher is, given the advances in modeling and compute power and everything else, like in the research community, where do things like generalized understanding, reasoning and other efforts towards more general AI stand? Are they all put aside because the focus is on large language models, or is there a potential for a breakthrough in one of those technologies that would lead to this existential threat that I think everybody thinks about?
I'm glad you asked that question, although I kind of want to push back on the last bit of the premise. In AI research, there are certain things that are missing from large language models, and you mentioned one of them. And so I'm looking forward to the work that's happening now, which involves things like reasoning of the sort that is not going on in this sequence prediction model. So predicting one word at a time, these models are so powerful, they can simulate what looks like reasoning. In fact, there's been a pretty successful set of techniques from a paper that came out, I think only in 2022, called chain of thought reasoning, which showed that instead of just asking one of these models for the answer to a question, what if you had to go through, suppose the question is like a word problem. You can ask the model, well, first, and you can train it to do this, why don't you go through the chain of thought that a middle schooler would go through before arriving at the answer? And sure enough, when you ask the model to output this chain of thought reasoning, like, well, because car A was going at 25 miles an hour and because, right? It spits out all the reasoning. Reasoning often is correct, not always. You will more often arrive at the correct answer. But all of this is still a simulation of actual symbolic reasoning. So yeah, there are researchers who are looking into combining the type of reasoning that we think of when we think of logical reasoning and these incredibly powerful models. So in a way, these models are so powerful that they, it's true, probably diverted attention away, but not all of it. And if anything, I think there's possibly more and more attention being paid to things like how do we add reasoning capabilities. There are a couple other crucial bits that are missing, like episodic memory. There are two main sort of kinds of memory. There's like general knowledge that you acquire, and then there's episodic knowledge, like knowledge that you acquire for things that happen, and then retaining that and being able to refer to it. There's working memory, or something similar to the way we have working memory in our brains. We'd like to maybe have something similar, would be helpful in the context of these types of models. So there are a number of different things that are under scrutiny in the research community now. But again, I don't think it gets us to like, oh, and then it means there's an existential threat. I just think it means then we'll have these fascinating and much more interesting and powerful and capable models that we can build. Sorry, that was a long-winded answer. I'm a PhD. I'll like, I'll blurt out my thesis at the drop of a hat. But yeah.
I'm just going to drop in. So speaking of the sophistication and the power that is out there and upcoming, when you think about careers at all, there's a lot of different areas where it seems like AI systems are going to replace different things. Have you thought about what you might advise a young person? I know there's some young people related to you in the audience, but have you thought about where those careers are going to be, or what careers might be more interesting and productive in the future?
I mean, I have thought about it. Yeah, I think these tools are the tools that we have now, and the tools that are coming down the pike are getting such that we will free us up to do more than we could before. And it's true, they're going to possibly automate some things, but that can be a very good thing. I was just chatting before this with Travis Bell, who is the excellent sound engineer who runs Verso Studios, and there are fascinating and amazing tools that help with audio recording and music production. That, side note, I write music, and I'm super excited about using extra tools to help do what I want to do creatively. And so when I talk to young people, I often mention that it's great to familiarize yourself with the latest tools, because great, embrace them. Use them to do things that you couldn't do before, or things that you could do before but now can do more quickly or better, or explore more interesting ideas and get more creative energy from. I think that's wonderful. So, and in terms of careers, yeah, embrace them so that you will have a career that makes use of these tools. People are doing it already without my mentioning this, so I don't even have to say a word. You can sign up and start using an AI agent of your choosing now, and use it to help you. Use it simply to get ideas and get more creative.
Awesome.
Thank you for the informative presentation. Throughout your talk, you had mentioned that many of the approaches of developing AI have a lot of similarities: large language models, transformers, and so on, all of which were designed and developed by humans. What's your perspective on AI being rewritten by AI itself and removing human from the equation, if we're perhaps reaching certain boundaries by humans applying their own knowledge on how these systems should be designed? Do you expect that to come in the future?
I expect some version of AI writing AI. What I mean by that is, right now, when a software developer wants to write code, that software developer can make use of auto-generated code as an aid. or make use of a large language model, say, that's trained to do this, to help debug code and spit out better code. So that's already a version of what you're talking about. So just imagine that getting better and better and better over time. The way I can see things unfolding is that when such tools become more and more powerful, the inputs that they'll require might be less and the outputs will be greater than they are now. Right now, there are limits to how well the current crop of LLMs can deal with things like code, right? You can hand it, I don't know, a page worth of code and it will maybe do a decent job of debugging it, or maybe it can spit out a page worth of code, but it's not going to be an entire system, nor is it going to debug your entire complex system that's made up of millions of lines of code. But the tools are going to get more powerful, which means we're going to be able to do more with our time as architects and developers of systems. So I don't see it as like, oh, what's going to happen when AI is writing AI? It's more like the tools are going to get so much better, and so we're going to be more facile at doing what we do already, people who are building technology. And then more democratized in the sense that wouldn't it be wonderful if you didn't need years and years of study and training to do some of the things that are done now by, say, people like me.
Hi, thank you very much for the presentation. Really enjoyed it. The downside of being the fourth person in line, two of the questions are already asked. But my question is about how do we take the AI to globalization? So think about it. Right now, we're talking about the AI just like writing the code for us, or predicting the menu for a party or something like that. But globalization in terms of using all the tools that we have globally, like shipments right now, or any changes going on, United States versus Europe. We can even talk about like a PII, personal identifier information, the usage of it. How is AI is going to be trained, or how are we going to be able to build the boundaries around AI to be able to not touch those? How are we going to control AI as we explore the whole globe?
That was a big question. So let's see. Yeah, there's a lot in there. I work with some really talented people at Meta, and I worked with really talented people at Google who are working on problems involving ensuring that that large language models deal safely with a sensitive information like personally identifiable information. And so thankfully there's like a strain of research that focuses on that area, and practitioners who are at places like where I work, who are very thoughtfully trying to mitigate risks when it comes to these types of models. So yeah, putting boundaries, I mean, that's kind of what those of us who do work on mitigating risk and work on safety and large language models, that is an area unto itself. So that's part of how it works. I guess the question about how is it going to work globally, yeah, I think there was maybe a bigger question in there about how will it affect international commerce and politics and world affairs.
Skip that.
Yeah, I'm gonna sidestep that and fall back on the I'm just a research scientist. Even though I do like thinking and talking about policy questions, but maybe we can chat about this afterwards. Yeah, but I can tell you that there's thankfully a lot of really great, thoughtful people working on how do you build safety and mitigate risk when you're building these types of models.
So Dan, in December, there was an AI summit in Manhattan, and I counted no less than 6 different companies they were offering to mitigate hallucinations. That's become a business, right? Hallucination Mitigation, Inc. So could you just talk a little about hallucinations? Is that the right approach, that you should have like a separate system that's looking at your outputs?
So, yeah, I'm glad you brought that up. So first I would say we would have to figure out what people mean when they say hallucination. That term itself has different meanings and I've seen it used to mean things pretty narrow and pretty broad. The narrow view might be, so one of the areas I work in is an area called retrieval augmented language modeling. And this just means when you're trying to get the LLM to spit out words, before it does that, you use this other system, a retrieval system, to get the most relevant pieces of information according to context. If you're building a chatbot, the context is like what's going on in the conversation, for example. So one version of hallucination is the LLM shouldn't, if at all possible, spit out words that, or information that is not somehow present in that set of retrieved items. By the way, we use machine learning often to do this type of retrieval. That's a pretty narrow and good working definition of hallucination. There's a much broader definition that people sometimes use when they say hallucination, that they mean the model shouldn't ever say anything untrue. And that's a biggie, because first of all, what does it mean for something to be true? And we can get into some deep philosophical territory, but I like the narrow definition just because we can operationalize it a little more. And that's, by the way, the reason I spent all that time talking about retrieval augmented language modeling, that's a method that is not extrinsic, but is part of the system. So you can retrieve and generate, that's what retrieval augmented language models do, and you can either in the generation, during, before, after, help ensure that information is grounded in those knowledge sources. So that's an important thing to do. But you can also do it externally, hence the rise of all these companies. And I would, one more thing about that is that there are multiple sources of information that can be brought to bear with these large language models. Like there's the gigantic source of information, which is we call pre-training. That's where they're just given lots and lots of text. But then there are these sources that you might retrieve from, like maybe one of them is, I don't know, the CDC or the National Institutes of Health, and there's a lot of good medical information there. Or maybe you have Wikipedia, which is a high quality source. So grounding information, yeah, super important, and we luckily have a bag of methods that we can use to help do that.
Great.
We have time for one more question,
One more question. All right, you're the last one.
I'm a student at Lehigh, and so I see students using ChatGPT or any given AI really every day. Where do you think AI has a spot in education?
I think it has a large role to play, or will have a large role to play, in I think a good way. Obviously, there are dangers here. I mean, just as there were dangers before this thing came along. It's not good to write an essay and just copy paste from Wikipedia. So please don't do that. But I think it has a great role to play in terms of, just like I was talking about before, with the ability to interact with something, you have more possibilities to have a kind of virtual tutor. Doesn't mean you don't need humans to help you learn, but it's a way that maybe on your own time you have this other powerful way of learning that you didn't have before. Maybe before you could write, you could reflect, you can read, you can do more writing. Now you've got this interactive tool. So I think it has a great role to play with that, great role to play. They're obviously good at generating text. They can be used to help you learn to be a better writer. Possibly even by you as a person critiquing the output and observing where it falls short There's good writing, there's bad writing. We can use this tool also to help us discern the difference. And a human teacher can help you discern the difference and make use of this as a tool.
Excellent. Well, that's a really practical spot to stop. Thank you so much, Dan. I really appreciate it. Thank you all for being here.